In this video, we'll be making horns, as well as a scaly tail using CurveSuite. Both of these workflows are relatively similar to one another and won't take that much time, so they will be condensed into one video. Here we have a basic Blender scene, which I'll start off by getting rid of the timeline window, deleting all the objects, and opening up our asset browser window. I will add an Bezier curve object, which will be our horn. I will go ahead and drag the deformed rail on curves modifier on it. I will add in a cylinder object and reduce the vertex count to make it easier to work with, which will be our horn profile. I'll offset it on the x-axis, all of it, so it's not in the way. I'll set it to shape smooth, and then get rid of the top and bottom faces. Back at our horn object, I will go to the modifiers panel and select our horn profile object for this parameter. Now we want to line it up so that the curve itself is following the direction that the horn will. And we want to set up the modifier and as well as the profile object such that the z-axis for the horn profile goes along the curve's tangent. There are a few ways to do this. One is by using the rotation parameters here. And having just a 90-degree rotation along the y-axis seems to line it up. But there are two more alternatives to this. If we have the Apply Transforms checkbox enabled, you can see that any edits you make to our horn profile object in object mode actually reflect onto the horn curve object we have. So rather than messing around with the rotation parameters in the modifier, you could try and line it up like that by rotating the object itself. Alternatively, if this checkbox is not checked, any edits in object mode do not reflect onto the horn object, and you could rotate it in edit mode to try and line it up. But for now, I will just enable Apply Transforms, but then handle the rotation within the parameters. I will increase the count, because if we enable the wireframe view, you can see if we have a count of 1, it just stretches this singular cylinder across the entire curve. But if we increase the count, then we get more polygons to work with. I will adjust the curve shape and radius a little bit while we're in this stage. This is a good enough stopping point for now. Now in our horn profile, I will showcase the main advantage of using the deformed rail on curves, because so far we could have just used the curve to mesh modifier to have this shape such that the edge loops are actually connected to one another rather than being split. But because we are using a mesh, we can actually create shapes that would have been much harder to create using the curve to mesh, or possibly even impossible. The instanced horn profiles along the curve actually retain all the attributes of our horn profile here. So any changes we make in edit mode, or as far as the options in the data panel goes, they will be retained. So for example, we can mark sharp, use auto smoothing, One important detail to notice that I will just enable the bounding box for our profile. When the profile is being instanced along the horn, the actual object center is being used as the reference point for which the profiles will be placed along the curve. So for each instance profile, this point, the origin, will be where the curve is. And if we go to edit mode and offset this profile, you can see that they are being offset in the horn object itself as well. This can be useful to create spiral patterns and whatnot, where by creating a gap here, you can affect the positioning of the instance profiles. But if the object is too far pushed along the z-axis, it can create a situation where the created horn doesn't really line up with the actual curve itself anymore. Because if the instance profile overflows the curve itself, it will just follow whatever direction the curve tangent was pointing at. There are two ways to fix any potential issues with this offsetting. One is if you enable use center as origin, the modifier will calculate a new point to be used as the object origin, which was identical to setting the origin to be the geometry. So if we disable this, you can see it has the exact same result as long as the object origin is at the center. Another thing to note is because we use the bounding box, or rather this modifier uses the bounding box of this profile to create the instances, if there's a point or a vertex that actually points or it sticks out of the rest of the mesh, you can have these gaps within the profiles that are being instanced along the curve. But this is a relatively easy fix, where as long as you just make sure that the edge loops that are on the borders are perfectly scaled flat and nothing else is flowing outside of that boundary. This was a relatively simple example, and now with another example I will explain the bounding box group parameters as well as the radius effect on x and y scale parameters. Here I've created a slightly different shape of horn, and with our horn profile object I will go into edit mode and then extrude this part upwards, all of it. Now immediately we get these gaps in between the profiles because the bounding box itself is being changed. But this is where the bounding box group and group cutoff parameters can be handy. If we go to edit mode in our new horn profile, I'll create a new vertex group and call it BB. I will select the vertices where I want the bounding box to be taken into account and assign these to the new vertex group. And then with our bounding box group, if we just type in the name of this vertex group, suddenly only these vertices are being accounted for when calculating the bounding box and placing these instances, which means we can create patterns that actually flow outside of their own boundaries, so to speak, and into the next profile along the object's or the horn's length. can see if we disable the bounding box group, the old bounding box or the entire bounding box is being used for the instancing. By specifying this group, we can actually have this part of the horn flow over, in a sense, which can be useful. As long as you make sure that the vertex group itself is consistent. Because as we can see, because we had 1 set to these vertices and 0 set to those, this new edge loop had a 0.58. But this is where this group cutoff parameter can be useful as well, because you can make it so only vertices above a certain weight are considered from within the group. But it is most of the time safer to just make sure that the vertex group assignments are proper and consistent. But this can still be a useful parameter to configure. Now finally, we have our radius effect on X scale and Y scale. Normally you can scale these profiles uniformly along the X and Y axes using the curve radius. By reducing this parameter, we can disable the effect the radius has on along a certain axis. There's actually another benefit of this. You can see these have the input attribute toggle buttons, which can actually use vertex groups from this horn profile object. So if you get a new group called X and another called Y, I'm going to exclude this part and then assign the rest of these vertices to be in this group with a value of 1. Now if you go here and press the button and type in X and Y, you can see that the vertices that don't belong to those groups are not being scaled, whereas the vertices that have been assigned are. So at this point, you can assign a different value to the rest of these vertices. For example, you could set them to 0.9, and they would be less aggressively scaled by the radius parameter. We can shrink the actual center of the horn almost all the way down to 0. But these protruding spikes do not get completely erased because we have set their value to be a different value than 1. I hope this is a proper demonstration of what can be possible using these parameters. I know it's not a very aesthetically pleasing example, but I hope it still helps you utilize it in your own work in some way. Up next we will be working on a tail, which will follow mostly a similar procedure, but with a few added steps, because the profile itself will be more complicated than this. The start of the tail workflow will be almost identical to the horns, where we start off with a fresh scene and then add in a curve object and a profile object. So these parts will be mostly sped up. For the tail, I want the top side of the profile to have obvious scales, but the bottom part to be somewhat rectangular plates. To accomplish this, I will select the bottom half faces, insert them a little bit, and then use Alt-S to fatten them. Then I will use the rotation parameters to make sure the alignment is correct. Now for the top part, where the scales will be, I'll be adding a new object and call it scale. And we will be instancing this onto the tail profile. Once we have a base shape going on, I will enable the wireframe view overlay. I will add in a new edge loop along the center of our tail profile because this will help with the placement. I'll make some adjustments to the top side of our tail shape because I want it to be a bit flat. I'll also slide the edge loops a little bit so that the face sizes are a bit consistent, or at least a little bit more consistent than before. I will scale down our scale object in edit mode. This is crucial that we do not do this in object mode. And then I will enable vertex snapping with active, and I will enable align rotation to target. Now, by placing our scale in a convenient spot, we can create link duplicate using Alt-D, and then placing these duplicates on the vertices of our tail profile. One thing that is important is that you try and create duplicates of our initial scale with no rotation, because if there is a rotation value for the object, the end result can have a weird offsetting going on. So that working with the copies of an object with no rotation data guarantees, or at least borderline enforces, that these issues will not happen. Now, we cannot do any edits in object mode, but any edits we do make in edit mode will reflect onto all the other scales that we've created. So we can make adjustments to make sure that they're not overlapping with one another, but also making sure that they do not have as much of a gap in between them. Now at this point, one thing you could do is select all these scale objects and then our profile, and then join them and use a vertex group like we did with the horns to make sure that these scales aren't included for the bounding box calculations. But there is another way that is much more convenient and retains the editability, or rather the convenience of having used instanced scales. So I will create a new collection and call it tail profile. And within our old collection, I will select all the scaled instances as well as our tail profile object and move them to our tail profile collection. And I will parent all the instance scaled to our tail profile object and keep transform so that they move together. Now within our previous collection, I'll create a asset browser window again. I will insert in any mesh object, doesn't really matter what it is. I'll call this tail profile complete. Underneath the miscellaneous modifiers, there's a modifier called join collection as object. I will drag and drop this onto our tail profile complete. And here I will specify our tail profile collection. Should then make this so that this object is an exact joint copy of all the objects in our tail profile collection. Now I will select our tail profile object and reset its position in world space. because with the way the objects are instanced in this join collection as object, their transformations in object mode all carry over. So we want this to be in the world space origin. And now rather than selecting our tail profile object, we can select our tail profile complete object. And we will have to realize instances for the tail object to recognize these scales and the profile. Because if we do not realize instances, these do not actually retain their own mesh data. They're just exact copies of these. And the modifier itself does not recognize these copies. It only recognizes the mesh data. So it treats them as blank. Now we can hide our complete tail profile because we won't really be using it for anything. Under our tail profile object, the initial one, I will create a new vertex group to be used as the bounding box group. I will exclude these scales. The scales will not have this group, but they do not need to, because we want them to overlap, in a sense. Now, because we are still creating, or rather using the instances of this scale, we retain the ability to make edits in edit mode, which will actually reflect onto these instances. But unfortunately, as long as we're in edit mode, we do not actually get to see them happen on the tail. So we will have to look at our tail profile here to make sure that we get the result we want, in a sense. I hope this is a good demonstration of what is possible using even just two modifiers. If you have any suggestions or questions, feel free to leave comments and I will try to address them as best as possible.